Welcome to the Tech Connect podcast. I'm Jason Martin, and I'm joined today by JC from the SoCal Tech Forum and Andy Gryc, the Developer Ecosystem Director at QNX. In today's episode, we're going to explore the world of embedded systems and real-time computing with a company that's been a core part of this industry for decades and is now deployed in over 275 million vehicles on the road today. We're also going to hear about the QNX Everywhere initiative, a program that provides free, non-commercial access for hobbyists, students, and even professional developers to learn and grow through the QNX software development platform. All right, thanks for joining us today, Andy.
Absolutely, my pleasure.
So to kick us off, maybe you could tell us a little bit about yourself, your background, and your role at QNX. I saw you started off as a software engineer, so super interested to hear about your journey and what brought you to your role at QNX.
Sure. I started kind of young. So I started, I think, was it maybe seventh grade or something like that when my dad got a computer. And I didn't have any money, as you might imagine, as most, seventh graders don't have a lot of money. And so I basically decided, well, I want to play video games and I can't buy them, so I'm going to write them. So that kind of started me doing that. And then, because of that, I ended up getting a job that I was able to work at high school and like an actual, job. I was at the time, it sounds funny to say, but I was doing quality control software for like automotive kind of stuff. So I was learning all about like X bar and R charts and all this other kind of crazy stuff and capability charts and whisker charts and all this. And I was doing that like in high school. So I was like pretty far ahead of like at least in my school classes, like when I went to university, because I was like, oh man, I love programming. This is like the funnest thing. I can't believe I would get paid to do this because I would probably be doing it for free if I didn't. And I went into that. I can't say that I was as skilled in all my non-computer classes. So, that's probably a different story. But, on the computer side, I was actually pretty focused. And then I ended up getting a job at HP because I wanted to do something really cool. I had a calculator that I used throughout my classwork, at university. I said, man, it'd be really fun to work there. So I applied there and I got in. So I was doing that kind of stuff. And so that kind of like got me like seasoned more as a programmer. So like when I was doing my other kind of job, it took a while for me to realize, I wasn't just the greatest thing since sliced bread, right? Like, I mean, it took me a while to meet other programmers and get humbled, and that was actually a good experience for me to kind of like go, oh, okay, it is good to actually like sort of step back and realize you're not the center of the universe. But I was a young kid, right? So what did I know? And but that was kind of good as well because I sort of had a chance during HP to like do some things where I was like interacting with people. Like we did a little bit of developer outreach as part of like the program that we were working on. So we were doing the HP 100 and 200 LX. So they were these palm top kind of things. So like, way back when like when PIMs were a thing and PDAs and all that kind of stuff. And so we would have these, I mean, we'd call them AMA sessions now, but we basically get on to, the tin at the time. We'd get onto like news groups and people would ask questions and stuff like that. And so it was a very early taste of doing that. And I thought, wow, that is really fun. I like doing that. And then I've had sort of chances to kind of also improve my skills in terms of doing, like just public outreach and various different things. And so that kind of culminated in getting a job at OnStar, where I was kind of like starting to get into less programming centric. And, like at that job, I was basically doing system architecture stuff, but for like the telematics unit, but not coding. Though I couldn't help myself from coding, but it was, like it was all requirements based, right? So it was all, oh, you're going to tell somebody else how to build it, and you have to write down the requirements. And it was like, so that was a unique thing for me. I was like, oh, okay, well, that's okay. I mean, I'm still kind of relating to the tech. I'm not doing the tech, but somebody else is doing it. And then from there, I got a job at QNX the first time around. So actually, I come back the second time. But so the first time around, I was doing, kind of a worldwide FAE and, all these other kind of things. And just sort of like as like my career progressed, I was doing less hands-on and more kind of like evangelism or, talking about what the company was doing and things like that. Went into product marketing. Then I did my own job or created my own company for like 11 years and did that. That was all technology marketing based. But then, I talked to my old boss and he had a role and I was kind of bored and looking for something new to do. And so, yeah, it was kind of really cool. So I said, yeah, you know what? That sounds like a super fun job. I totally want to do it. Get me back in. So, so here I am. So,
Very cool, very cool. And so with QNX, QNX is in the world of embedded systems, real time computing. It's one of those brands that I think is everywhere, but not a lot of people see. Right? It's powering a lot of the systems that we rely on, like day to day. So maybe you could tell us a little
mhm.
bit about QNX and their platform and what you all do.
Yeah, for sure. So that's actually my biggest challenge is telling people who we are, and then they go, "Oh, I never heard of you." And then we say, "Oh, we're a division of BlackBerry." "Oh, I've heard of them." And it depends on the age of the person that you're talking to. So sometimes they're like, "Oh man, I love my Bold" or whatever, and then like young kids will be like, "Ah, BlackBerry, no, I never heard of them." So it kind of depends on the age. "Oh, but my dad has one," that kind of thing.
Yeah.
So we are a division of BlackBerry. We're BlackBerry basically acquired us in 2010 when they were doing the new BB10 operating system. So that operating system is based on QNX, and they used us because they loved our track record of like being able to supply software for high reliability applications. So basically, that's kind of the thing we do. We create an operating system. It's POSIX compliant, so it looks a lot like Linux, but it's used for mission critical type of software. So we're like the predominant OS in cars, for example. So in lots of different sorts of applications, we're in, like robotics, medical equipment, like MRI machines, CAT scans, surgical robots, energy creation, like windmills, all sorts of different applications that you kind of don't want to fail, right? So that's sort of our claim to fame. And yeah, it's this role is sort of trying to like educate people about who it is that we are and what we do so that they can kind of put the pieces together and say, oh, okay, cool, that's something I've been interested in and I'd like to go into that field.
Yeah, yeah, absolutely. Because a lot of people, I think, don't think about that, and like some of the software behind what powers everything and how important it is. A lot of times we're exposed to more of like the consumer electronics brands, and we think about those first, and what's necessarily in the news. So
Hmm.
that's really cool. I mean, in my one of my past jobs, I worked for company that made networking components for industrial like automation and all that, and just the reliability tolerances and the required uptime and everything is astounding in some of those industries. So
Yeah, no, that's for sure, and that reliability. I mean, when you're saying, like who is QNX or that kind of thing, when we actually start explaining, like those use cases, like the kinds of things that we are, I think a lot of times people don't realize. Like what embedded software is and how prevalent or how ubiquitous it is. Like it is everywhere. Like there are computers in nearly everything that you look at or touch. I mean, except for maybe furniture, but that's probably coming, right? And also just sort of just all of the different kinds of ways that those things show up. And so the fact that we can have like an engagement, like a lot of the things that I do right now is like university or academic outreach, right? So I'm talking to tons of students, and you can see their eyes light up when it's like, oh wow, so you guys are in like cars and also washing machines, like what's that all about? And it's like, well, I mean, not all washing machines, but the ones that are like super complicated and like have all these kind of things. Yeah, we're in some of those kind of things or whatever. Like we're in places that we wouldn't even really think about.
So, Andy, how do you define embedded systems and just real time computing?
uh yeah, that's a really good question because I think that I think it used to have a real clear-cut answer, but I think that that answer is slightly less clear-cut now. But I kind of define embedded systems as everything that's not a cloud and a desktop. You used to say, oh, is everything except for, like the PCs, on your desk and stuff. But then cloud kind of like blurred that out. And like, industrial IoT and, edge computing and a lot of those other things kind of blur some of the lines there. And, another easy way to say it used to be, oh, it's anything that doesn't have a screen, but then screens started showing up in like industrial automation or in, like all these other kind of applications. So it's sort of like, I think that one kind of common defining characteristic is often that it's not intended to be, well, see, even here I'm about to contradict myself. It's not usually intended to be, modified by the consumer, but there are kind of the right to repair and things like that, and some people are doing things that are open source that are embedded, and they are expected to be modified. So even that is a little bit blurry. So yeah, but it's all the hard stuff is kind of one way to think of it. It's the stuff that you're not like programming on your laptop or your computer. And then the other part of your question, JC, about real time. I mean, that has always been a very blurry question. And I would say, a lot of our applications are not real time. Like people use us for the reliability aspects and don't have real time requirements because real time means something very different depending on whatever the industry is, right? I mean, like there are industries where real time means failure to respond within like 50 microseconds or something like that, 50 millionths of a second, right? So it can be extremely strict for some different industries, but other ones might say, yeah, real time is if I don't actually be able to send like like an SOS message within 10 minutes of receiving that thing, then it's a failure. And so the difference between 10 microseconds and 10 minutes is like massive, like
Right.
massive orders of magnitude. But they both have a common characteristic of if you can't do the thing that you're supposed to do within a set deterministic amount of time, then it's a failure. It's considered a failure and it's considered that the system isn't working properly. And so that's kind of where it comes up to, regardless of whether it's hard real time, soft real time, whatever that is.
Well, that's awesome. It's kind of philosophical, actually. I didn't really think
It is.
Yeah,
Yeah.
it
Yeah, it
gets to
is.
that level, which is kind of my jam. But you mentioned a couple industries. Why do they choose? Like, I understand they set their own tolerances. What would be the top industries, 100%, the mission critical? And you mentioned a couple, like automobile, medical. What would you say? I don't, not necessarily name drops, or maybe you can. I don't know. Could you enlighten us on that, Andy?
Well, it's easy to do that on the automotive side because basically nearly every automaker uses QNX in some way, shape, or form. There's one notable exception, which I'll leave off of there. I'll let your readers or listeners guess as to who that might be. But we're used across the industry for most traditional OEMs and even a lot of the new EVs. And there's a couple of fundamental reasons why that is. One is that we have all the automotive certifications that are needed for putting software together. So it's probably important to talk a little bit about that whole process of certification. So certifications don't magically make software better. They don't magically make things safe. They don't magically make things cyber secure. But what they do is they capture a defined rigid set of processes that say you have thought about all of the things that could make this fail and you've done things to mitigate it. So it doesn't magically make bugs go away, but what it does do is it says your engineers are actually actively thinking about the things that cause things to crash, that cause problems, that could be unexpected inputs, that you're going to respond to those. And you have a defined process for doing that. And you can talk to an external auditor who can come in and confirm that you're doing all those things. And to do that is like a massive pain. It's a lot of work. But it's work that isn't typically done only by engineers. Like engineers have to create a paper trail, but then you also have other people in the company that will follow that help ensure the processes. So the whole thing about certification is only really done when it's absolutely needed to. And so regulated industries will choose those certifications to help them ensure that the software that people are creating within those industries is actually, going to be, legitimately functionally safe, or in other words, will protect human life, and or a damage to property, or whatever those other characteristics that they're trying to go for. So that's one of the reasons that we get chosen, because we have all the certifications for all those different kind of things, and we follow all those processes. Another one that we get chosen for is just the inherent reliability of what we offer. So we offer something that's kind of interesting, because from an API level, actually, I do have one pause. What level of audience are we, as your podcast listener typically? If I say APIs, do I have to explain what that is, or should I assume everyone knows what that is?
It's a pretty wide range. I would say it's safe to say that most of our audience is
Knows what
technical.
APIs are.
Yeah.
Yeah. Okay. So I mean, we have APIs that look like POSIX, which basically means we look very much like Linux from a programmer's point of view. So if you're creating applications, we look a lot like Linux. But underneath that, so the actual operating system itself is nothing like Linux. So we have what's called a microkernel architecture, and that's an operating system basically has code that runs in two sort of different modes. So one is in kernel mode, and kernel mode is essentially, it's kind of like root control of the system, right? The software can look anywhere it wants to. It can do anything it wants to do. It can write memory anywhere, and it's responsible basically for the safety of that thing. And then there's user mode. User mode code is not trusted at all. If it writes outside the boundary that it's given, it will crash. And that crash is basically a signal that, hey, your code isn't doing something right. You got to go fix it. So the primary difference between something like QNX, which is a microkernel, and something like Linux is that because we have a very, very small amount of code that's in kernel mode, so there's very little code that's trusted, and that code is code that we've basically spent 46 years trying to work on, refine, build all that stuff. Everything else in the system, all device drivers, all networking stacks, file systems, like USB stacks, anything that writes to hardware, all your applications, they're all running in user mode. So that basically means anything that happens within the system that crashes will, basically just crash that process. It doesn't cause, like the OS default, it doesn't cause a blue screen of death. It doesn't halt the system. And to get it back to a safe state, all you need to do is restart that process. Now, I say all you need to do, and I'm doing air quotes for the benefit of those people who are not watching. I mean, it's actually a little bit more complicated than I'm making it, because, like any applications who have been using this process that dies have to be smart enough to be able to say, oh, like that file system just went out from under me. Your normal application isn't written to behave that way, because if that happens, the OS is dead and you don't care and you have to reboot anyway. But on a system like QNX, if you want that thing to run, you have to be able to respond to situations like that. If the file system goes away from under you, you have to be able to say, oh, okay, I got to close all the file handles I'm using. I have to like reopen them. I have to make sure that I go back to where I was. So there is some like maintenance code and some like, little fiddly things that have to be done to get yourself to be up back to a safe state. But in those cases, you can do that. And we have systems that have been running for, like decades, literally, that have not rebooted like in 10 years or more.
Wow.
And in fact, there are problems when they reboot, because it's like the hardware has failed in the interim. Like some hardware isn't designed to never be used, like, so it's like they go to reboot and they try to boot back off of the disk, and it's like, oh, well, that not only does that disk not work, but the manufacturer doesn't make it anymore. So what are we going to do? Like I remember actually having to go out on eBay and try to help a customer find a disk so they could boot back up the power plant that, like had never been rebooted before, So, I mean, it's funny things like that. But, like that's one of the things that makes people choose us is that reliability, or that ability. I mean, there's a bunch of stuff to talk about. I don't know how deep we want to get in that, but there's a lot
Well,
that's there. I mean, and yeah,
I
go
was
ahead,
gonna say,
JC.
like, you listed a bunch of advantages. We see our little guest real quick. I like it. You listed a bunch of advantages. What about some of the uh, the trade-off, just for our
Disadvantages.
listeners.
Yeah.
Yes.
Yeah, no, that's fine. I mean, it's fair because you don't get anything for free, right? Like, so something always comes at a cost. So the cost for us is that in order to make a system like that, where all of those different components are completely isolated, running in their own user space, in their own virtual memory, uh, processes have to communicate by sending messages to each other. So so let's just take an example under like Linux. Let's say you have an application that wants to write something to the file system, right? So all it has to do, and again, I'll say all, but what it does is it basically calls a function that writes to that file system, and that eventually gets down to a kernel call. But you just pass a pointer to the buffer that you want to write, and the kernel says, oh, okay, great. There's that memory block of memory that he wants to write, or he or she wants to write to that file. And then here it is. So I will just grab this, I'll put it in the buffer, I'll do whatever I need to do with it from there. In QNX, you can't do that because you're not allowed to basically share memory between processes. You can do it. There are things called shared memory, but both applications have to be written that way. So instead, what happens is we turn those calls to write to a file underneath the scenes into message sends. So we'll turn that into a send from one process to another. That other process will receive that message. In order to do that, the kernel has to copy memory from one block in the one process to a block in the other process, and then tell the other process to go ahead and take it and run with it. So first of all, we copy that memory. So there's two copies of that buffer. And second of all, we have to actually copy it, physically copy it from one place to the other. There are a lot of tricks that we use. Like, so for example, if you're writing large blocks, what we'll do is we'll actually map some pages in the page table from one process to the other, so that we can say, oh, if he's dealing with a massive amount of memory, we don't want to copy that. So we'll actually like block over some things in page table, put them in the same place so that he has actually this other process can access that without having to copy it. But that's very expensive to do because it requires things like invalidating caches and stuff. So you don't do that unless you're serious about it, right? But I think fundamentally that trade-off, when we started the company, I say we, when the company was started, I wasn't there, but when the company was started, it was like in the 80s at some point, and processors were way slower than they are now, much less sophisticated. They didn't have all the caching. They didn't have all the predictive look ahead, all of the things that make processors extremely fast. They weren't multi-core. They weren't any of that stuff. The processors that we have today are so much faster, so much better at predicting things. They have multiple different levels of cache. They use those caches very intelligently. So there's a lot of things that I think we do that now are kind of at the noise level, I would say. I mean, like, we don't really have the problems that we used to have in terms of, people going, oh God, this is such a hit on my performance. We used to have all those kind of problems. A lot of people complained about that. It's like, well, it's worth it for the reliability, but the impact on performance is so much, I'm not sure I can buy it, right? So, but what's happened is in the interim, we've spent a lot of time perfecting that code, making it work, taking all the the boundary cases. When it's really, really small, we'll just pass things in registers instead of copying it. So there's a lot of optimizations we've made. Processes have gotten a lot better, and people have gotten a lot more concerned about the ability to make software work reliably when they're putting it together from multiple different pieces, lots of different open source projects. Nobody writes all their own code anymore, right? Like, they're putting together all these systems from all these different pieces. So the reliability aspect has gone way, way, way up in terms of their requirements for how much the system should be able to do. And their concern and the impact of those copies and things like that has gone way, way, way down. So fundamentally, that is not ever an issue anymore. It is a penalty that you have to pay, but the penalty is relatively small, and it's one most people are willing to pay, at least for sure in the industries where this kind of stuff matters, right?
Yeah, very interesting. Because it sounds like when you look at the difference between like a microkernel operating system, like the first thing that comes up is like, oh, your trade-off is speed. But it sounds like from what you're saying is that like our processing power and just the way everything is built is the hardware is so powerful now that the trade-off isn't really necessarily that significant, maybe not as much as it used to be.
Yeah, yeah. I think also it's important to realize like the trade-off only happens when you're communicating between processes or you're communicating with, what you think is the kernel. Like if you're writing two files or you're, calling USB stacks or things like that. And in a lot of cases, you're not doing that kind of stuff, or that's not where the bottleneck is. The bottleneck is not for you reading or writing things out of files. It's for how many times can you iterate over this particular LLM or whatever before you generate a result, or like there's a lot of other computationally intensive things that are soaking up all of the processor time, and you're concerned. So like the things that you're doing to like read a file off of the camera or off of the disk or whatever, like the noise level that we're at is pretty minor in terms of like what the impact is.
Very cool. Very cool. So I'd like to switch to talk a little bit about your program, because it sounds to me like developing for like a microkernel operating system and for real-time computing and all that is it really needs, like, it's a different experience. And your program, I think, with the QNX Everywhere initiative really stood out to us, because like our mission is all about how do we help our members and our community learn all about like new and cutting edge technology and be able to grow through that. And with your initiative, you provide some of your newest platforms or newest software in a that you use for your large commercial customers, essentially for free for those that are looking to learn, like for students and hobbyists and all that. So maybe you could tell us a little bit about that initiative and how if a software developer wanted to get into this world, how would they leverage that to start getting hands on?
Yeah, absolutely. Yeah, it's kind of a match made in heaven, honestly, from your audience and what we're trying to do. Because, I mean, I think I can't remember if this was actually before we started recording or if it was after, but we had a conversation about how nobody knows who QNX is, right? And that like if I say, oh, I work for QNX, and they don't really know what that company is, and then I kind of explain what we do and all the places that we are, then people start going, oh, well, that's really cool. But that's basically the mission of what we're trying to do, because we really realized when our customers kind of started to tell us, it's like, hey, we love your software, it's fantastic, we're building our program on it, but we can't find developers. So we actually need to hire people who have QNX expertise. I mean, it's and that started to become like a serious concern for us. And we were like, you know what? They're right. It's like, we're kind of the best kept secret in the industry. Like, I mean, tons of companies use us, but outside of industry, like if you talk to just regular developers, or you go to universities and talk to people, like, have you ever heard of this company? No, like nobody knows who we are. And so that was we started about a year ago. So at last CES a year ago. Now about a year and a couple months, we officially launched our QNX Everywhere program, and that was a way to address the non-commercial customers of our software, or could be customers, right? So, I mean, we still sell our commercial product to all of those companies that we do, and if they're making money off of it, we want to make money off of it as well. It's a shared thing, right? But for all the people who could be contributing to the ecosystem, they could be developers that some company might hire, they could be creating open source software that some company might want to use. We wanted to do something to make sure that those people were getting support. So we did create QNX Everywhere, which is opening up the same development seats that our customers would pay for to be able to use, and use them for free as long as they're not making money off of it. We are not going to ask them for money for it. There's a few differences in what we're doing, which I think are kind of interesting. So one is that because of sort of how our standard product really does continue to have all of the same levels of certification and everything else, and QNX Everywhere is based on that exact same product. So you're getting the newest thing. And in fact, QNX Everywhere, you're getting something a little bit newer because it also gives us the ability to kind of do things that aren't necessarily fully, rolled through our standard process, right? So we can kind of do things like, oh, okay, cool. We launched the developer desktop as a really good example of that. And that is the ability to run like a windowing environment on a QNX system so that you can do development on a QNX system. And why are we doing that? Well, doing that fundamentally because cross compiling is hard. And what I mean by that is when you're building an embedded system, you typically have a host machine, so like a laptop or Mac or Windows or whatever, Linux. And that machine is building something for a target machine. So the actual piece of hardware that your code is going to eventually run and live on. But in order to do that, you got to tell the compiler all these kind of special things like, oh, okay, you're not building for this machine, you're building for another machine. And here's what that other machine looks like. So build all your instructions for that machine, use all the libraries for that thing. And so it makes it really hard to move open source packages over because most open sources assumed like, hey, it's Linux. You're just going to build it on the thing. And then once you're done building it, you just run it. And so that realization that's like, okay, we need to actually make it way easier for people to just take code that's already open source. We're already Linux compatible. Let's make it super easy for them to build it because people are using things like ROS is a robot operating system. So people use it to, kind of put all these different systems together on a cooperative tasks running together, or they're using MediaPipe, or they're using some other kind of like open source project out there. And we wanted to really streamline that. So all of that to say, so a lot of the work that we're doing is doing that outreach. Now that we have this program that gives our software out for non-commercial stuff, we're also doing outreach to make sure people know about it, to make sure that, like we're supporting the open source community as well, like making sure that our software, our OS will run the software that people want to port to it. So if people want to bring cool stuff to QNX, we want to make that easy for them, as easy as possible. That's kind of what the developer desktop is all about as well.
Very cool. So with this whole program, what, you said it's a little bit over a year old. Outside of trying to just build awareness of the QNX brand and its application and all that, what have been the challenges to building a program like this, and where have you seen, successes? Where have you, what wins have you had over the last year?
I should be better at remembering the stats because we did publish a bunch of stats like on the last PR that we did, and I don't remember exactly what those said, but I mean, we've gathered probably, somewhere around 13,000 maybe developers as part of the program over the course of the year, which I think is actually pretty good. It's not amazing. It's not like, Google, Microsoft, Amazon numbers, but like for a company that's relatively small like us, I think that's actually pretty good. I would say the biggest challenges in what we're trying to do is we have an awful lot that we're trying to do, and we're trying to do it with a relatively small team. So we have a number of people, like myself. Probably if you count between, all of the various different functions that are actively supporting QNX Everywhere, outreach is probably maybe 5 or 6. There's a bunch of people that are doing like the engineering side of it, like that are contributing to, the developer desktop or doing open source ports or stuff like that, and that number's a little bit bigger than that. But the specific outreach stuff is about 5, and it's really hard to scale. So that's one of the things. I'm specifically hiring for a role. I just interviewed a person today where we've got a couple of people in the pipeline. So I'm hoping to actually help by adding some people to the team, but trying to figure out how we reach the most people that we can with the resources that we have and the people that we have. It has been by far the biggest problem. And I think part of it is we're also in a learning process, right? So we've been doing this about a year now, and we've been doing things like participating in hackathons, or doing podcasts like yourself, or doing whatever. And we're just we're in a kind of an intake mode where basically somebody comes up to me and says, "Hey, I want to do this." I said, "Yes, let's do it." What do I have to do? Like I'm asking questions after because it's like I'm learning by every engagement that we have. Like, okay, this is very valuable. Like, yes, we should do that. Like, we actually put numbers through the roof by doing that exercise. Oh, okay, but this is something that spends a huge amount of time and only reaches that many people. And it's also important to note on that I think the other thing that's really interesting is sort of the trade-off, right? So like, and I'll give the example about two different university kind of things that we do. So one is we do hackathons, right? So we can go to a hackathon, and like last one we just did was a hackathon at University of Ottawa, and there were like 600 kids or whatever, and maybe a different one might have 1,500 people or whatever. So there's a decent number of people that we reach with that in with our message, at least that says who we are. So maybe somebody will walk away and remember who we are. And the people that participate in our challenge, they'll have a little bit more knowledge. Like they'll spend 24 or 48 hours with us, trying to use, like our software running on a Raspberry Pi, for example, and building something like a cool robot or, roving thing or a temperature sensor, whatever it is that they're building. So that's a very shallow but broad reach. And then we're also doing things like supporting capstone projects. So there might be like a third or fourth year student who's like, just finishing their university. They've got like a project that they're running, and that is like building a planetary rover with a team of like 20 kids. So those people get much more if we sponsor them and they're using QNX and they're doing all this stuff with it, they're going to have way deeper experience, but there's 20 people there as opposed to 600. So
Yeah.
we're trying to mix that as well, right? Like, I mean, we want to get awareness, but we also want to get like capability and skills, right? So it's sort of like, what is the perfect mix there as well? I mean, there are lots of things that we're juggling. But all I can say is that it's all super fun. So I mean, like, no matter what it is we're doing, we're having a great time doing it, and we're just like constantly learning and constantly having engagements with people like yourselves. It's just been really, really fun.
That's amazing. And it sounds like, with when we talk about the applications, I talk to a lot of our members who are trying to find new avenues into different industries and trying to explore, what kind of technologies they should learn. And it sounds to me like, specifically with automotive, it's blowing up in demand for, developers as the car becomes more and more as just a giant computer, right? So it sounds to me like, if you're interested in getting in the automotive industry, that QNX might be something that's good to have under your belt, because most of the auto manufacturers, leverage it, and you're probably going to experience it at some point in time. So, that could be a way to, create an edge for yourself in the marketplace as you're looking for jobs.
Yeah, no, that's absolutely right. And in fact, that's one of the things that in terms of like how I often engage with certainly like university audiences, but also, like startups and things like that, where it's a slightly different story in those cases. I mean, for like a university, it's sort of like they're all trying to tailor themselves to like, how do I get that job, right? Like, I want to get a job into something. And when they learn that this is a skill that can differentiate them in that wide pool of potential applicants, that you have a special skill that like the industry like relies on and nobody else has, that's definitely a leg up. And it's sort of the same thing like for startups. It's a little bit different, but it's sort of like you're using a technology that's been tried and true. So like when the VCs come and say, hey, like, we want to invest in you, and you already actually have half of the battle done, like you're using like a platform that already the rest of your industry is using, then they're more willing to actually engage with you and invest and think that you're serious and think that you're taking kind of that whole next step, right? And certainly it's true, I think, for your audience too, if they want to, parlay sort of their interest in playing with, different kind of things into a skill set that might potentially find them the next career path for them. I absolutely would say that that's something that they could do.
Yeah,
So,
absolutely. Very cool.
Andy, that leads me to a question. You got me thinking. Really, it's like I want to bookmark this, and what I mean by that is like the bookends. Earlier, you gave us a philosophical response as to what you define embedded systems to be. Could you give us another philosophical response as far as where do you think embedded systems are heading and
Mm.
future applications, emerging technology, AI, and tying to that same one, what does a future developer look like? What should they look like?
All great questions, really, and all challenging questions. So that's awesome. Um, I mean, I think to start, like where things are going. I mean, clearly, I mean, there's obviously no doubt that AI is basically making its way into most kind of platforms. We have a sort of an interesting relationship with AI because if you think about like sort of all of the things I've been talking to up until this point, it's sort of like like reliability, mission critical, like we're used in all these industries, blah blah blah. Um, Most of that stuff goes pretty well against vibe coding. You know what I mean?
Yeah.
So like we're probably not going to be doing it ourselves. We're like in a massive research process to figure out how is it that we take AI tools, which we know and we absolutely have tested and find them valuable, and use them in a way that's responsible to both ourselves and our customers, right? So, like, I don't think at this point we've looked at it and said, okay, yeah, we're going to use it to like start making kernel changes or anything like that. Those are always going to be something that we do in house, but with experienced engineers. But I think in general, the embedded space is going to be embracing more AI. And we're doing, I think, a few things to kind of help that. So, one is trying to ensure that the tool sets that they're using, so like if they're using TensorFlow, for example, we support that under QNX, like we have a port of that. So, like we're trying to essentially, if they're building physical AI or they're trying to do, AI at the edge or any of those kind of things, they're trying to incorporate AI into their product. We might not provide it, but we're going to give you all the building blocks that you need so that you can build your own systems to do that. And I think that most of that is definitely going in that direction. I mean, people are trying to figure out, how do I use this? How do we use this technology in a way that's going to, be of value, be something that differentiates? And I honestly think that we are still in a position in the industry where we, embedded is always a little bit behind the curve, right? Uh, Embedded always accepts technology that's kind of been, like sort of vetted out already. Like once it's been vetted out enough, then it's kind of like, okay, now we'll start building things with it. And AI is kind of like that same thing. Like AI is kind of prevalent everywhere outside of the embedded space, and it's really sort of just starting to poke its head into a few applications. But clearly, we can see what the trajectory is for that. It's going to be showing up in more and more places, and like I mean, people are adding CUDA or whatever, like all these different ways to access the GPUs that are on a lot of these chips. If they're not using them for graphics, then they'll be using them for AI and all that stuff. So that's one absolutely clear way that we're going to go. We're going to do what we can as a company to support it without trying to jeopardize, our existing business and our existing reputation for creating stable systems and all that stuff. And I think, the other question, JC, that you asked is a really, really interesting one because of that juncture that we're at. Like, what does it mean to be a future developer, and what's kind of skills you're going to need? And I get asked that question a lot, as you might imagine, with all of the different university kind of things that I talk to. And I think one of the key things that I've seen is, you need to still have a command of the discipline that you're in. Like, so I think it's very, very easy when get into Claude or Chat GPT or whatever, like all of those kind of things, and you tell it to write you some code and it does a great job, and you go, oh, wow, I don't need to do this anymore. Like I don't, like it's doing everything for me. All I need to do is figure out how to write prompts and I'm golden. And I think that's a big mistake. Not just because of the lack of where we're going as an industry, but I think there's been so many cases that have shown that like, the code that you get still needs to have a human, and I think that this will be the case for a long time, especially in embedded systems. We'll still need to have a human vet it. There's still going to have to be somebody that stands behind what that code does. Like it's different if you're creating like a Python thing to scrape some web data
Right.
and create a report. Fine, whatever. If that has a bug, nobody cares. if you're creating something that's driving on the streets and like, mistakes a stop sign for like a pedestrian and slams on the brakes and throws you through the front windshield, that's different, like, so you have to really, really, I think, still have some idea of what it is that you're doing and use those things as a tool. And I think that more and more we're going to see um, that use of AI not just to do the code, but to actually be sort of a companion.
Mm.
Kind of take up, like, can it do peer reviews? Yes, probably that's something it could be very good at. Looking at your code and sort of like a static code analyzer on steroids. Like it tell you things about your code or about how your code is organized and help you with those things. I think there is going to be a lot more of that sort of a tooling aspect to it. Um, Especially when I'm talking about the kind of industries that I'm talking about, like those things where you still need to stand behind the code as an engineer.
Hmm. Well, I mean, that's really awesome. I actually really enjoyed that, and it kind of soothed me a little bit too. I was like, "Ooh." You mentioned the certifications earlier, and I'm assuming you're mentioning like ISO, like 26262.
26262, yeah.
Yeah, yeah. And so I was curious, like, do they have, does ISO have guardrails for companies using AI to develop mission critical work or anything of that
Yeah.
nature? Like what does that look like? And should
Yeah,
we
that's
be
so that's
pursuing that?
also another really, really great question. It doesn't right now because it was created before any of that stuff was conceived, right? Like none of the standards that people have in regulated industries currently address AI because they were all created prior to AI. That doesn't mean that people aren't looking at it. Like there are, like entire workshops of experts. Like um, there's a man named Chris Hobbs who used to be a QNX employee, and I think now he says he's retired, but he's still doing work. So he's not retired. A lot of work he's still doing for us. But I mean, like he was telling me about a conference that he was just at, and the entire thing. And these people are all people that talk about functional safety all day long. That's what they live and breathe. And they're talking about how do we actually build functional safety with AI? Like how do we integrate that in? How do we test it? How do we vet it? How do we describe it in a way so that the AI can create something that is functionally safe? So this problem is absolutely being tackled. We don't have a solution yet, but I can tell you a few things I think we're going to come out of that. I think one is that we're going to come out of it with an idea of how there will probably be some AI models that are specifically created for doing safe code, and those will have a lot of inputs and restrictions on what they do that guide them in terms of just the same way a human engineer would do that. So the code that comes out the other end, it may still end up being vetted by a person, but it will actually be much more created with those sorts of templates in mind. And I think the other thing is that we'll have standards that will contemplate AI as an inclusion into the process so that they'll be able to say, if you're using AI, here are the ways that we think it is to use that safely. And to be honest, we don't know at what point that is right now because AI is moving so fast that it's sort of like the whole thing with like certain regulations and things like that. Like I remember when I was at OnStar, we were trying to get V2X technology working, but the problem is that industry couldn't agree on what they were doing, and every time we turned around, we was like, oh, we want to do something different. We want to do something different. And the government's kind of like going, okay, well, we're not going to mandate anything until you guys stop changing. And we're like, well, the tech's not going to stop changing. So you're just going to either have to pull the trigger or you're just going to have to not have a part at the table, right? And so that's kind of what's happening here. It's like AI is changing so fast, and people who are trying to build safe software with it or trying to actually understand it are trying to play catch up. But the entire time that as soon as they get to a point where it's like, okay, good, now we got this figured out. Oh, shit, there's another model. Like this one does twice as much. So
Yeah.
it's going to be a while before things settle down enough for us to be able to, as an industry, say, this is how you do it. And this is the right way to do it, because right now, nobody knows.
Yeah, absolutely. I think departments like our InfoSec team and procurement, like they're on the forefront of that. And Every time I evaluate a platform, everything has AI into it. So now I have to do like AI impact analysis, and I have to ask my vendors, like, can you demonstrate that you are in fully control of the data that you that you have your hands on, and things like that. So yeah, it's going to be interesting to see how that all shakes out and how that starts flowing into the various different requirements and certifications industry wide.
Yeah, I mean, Jason, that's a great point. GDPR is a perfect example of that. Like, can you actually prove that what your AI is doing complies to GDPR? And I mean, that's a very simple thing to state, but because fundamentally the way that we build AI models, we don't really know. We know exactly how they work, but we don't know how they work in the same way that we don't know how a human brain works. Like if you say, well, where's the part where you're thinking about, that particular you're not, there's no part. It's distributed all across my brain. There's neurons all over the place, right? And they have that same problem. You can't identify. It's not like a line of code. You don't go, there's where I added that particular feature. So understanding like how a company can build a model and then say, yes, I know that this is compliant to XYZ, whatever the thing is, it's impossible to do right now. I mean, the best that you can do is add guardrails after and add a bunch of data in a template that's fed into the model prior to a prompt. And those two things do not make a functional, safe audience, like people who are building things that can't kill people. They don't necessarily make those people comfortable, right? Like
Agreed.
It's not a guarantee. They're two band-aids on either side. And until we kind of figure out how do we do the band-aids, and I think we can, because we honestly, we do that with ourselves. We allow humans, which are kind of a similar, not exactly the same, but a similar model of a bunch of squishy connections that we can't guarantee, but we allow them to fly planes. We allow them to drive cars. We allow them to do all those things. So there is something that can be done. We just have to figure out how to apply it to this technology.
Absolutely. All right. I'm going to wrap us up because I'm sure we could talk with you for hours. Very interesting.
It'd be fun, but yeah, I know you
I don't know if
our listeners would
stick around that long. So this was a fantastic conversation that we had. For our listeners, for those that are interested in learning more about QNX and the QNX Everywhere initiative, especially if they want to poke around and try it out, where would you recommend them going to learn more?
Hopefully, if at least search engines work the way they should, if you just type QNX Everywhere, you'll get to a right link. But if that doesn't work, just QNX.software, go to the developer tab, and then you'll see QNX Everywhere shows up. And then right from there, you can download the software, play with it, do whatever you want.
Very cool.
I will also say that we also have a developer blog. I think there's a pointer on that page to it. So my friend and colleague, John Hannum, runs that. He's got a resources page that has tons of stuff like our Discord, how to get things running on a Mac, because we don't directly support Mac right now. I have a Mac, which annoys me to no end, so I'm trying to fix that. But, like things like that. So he's got all kinds of like little pointers, how to get like quick start images for Raspberry Pi, all of those sorts of things. So
very cool. All right. Well, this has been a great conversation today. Andy, I can't thank you enough for your time. Really enjoyed our talk today.
Yeah, it was my pleasure. Yeah, thank you so much.
Thank you, Andy.
All right.
Absolutely.
This podcast is brought to you by Human Studio. Human Studio is an award-winning design studio specializing in web design, branding design, video production, and so much more. We'd love to help you take your brand to the next level.
Thank you for listening to the Tech Connect podcast. Don't forget to stay connected and explore more at www.socaltechforum.org. We'll see you next time.